Twist ties. They're practical little fasteners that we see every day across grocery store shelves. Many of us are indifferent to tying a twist tie. We do it regularly. But imagine trying to tie a twist tie with just one hand. That's what the employees of Jake's Ice Cream have to deal with every day.
My name is Safik Soma.
My name is James Shu.
My name is Sanchana Konka, and we are Team SKX from Poolsville High School. For this year's SourceAmerica IDEATE engineering competition, we worked with Jake's Ice Cream, a handcrafted ice cream shop in Falls Church, Virginia that employs individuals with special needs. The shop also provides cake pops, ice cream cakes, and other confections. Our project focuses on the cake pops, which are delivered in plastic bags.
The owner of the shop, Dr. Robin Renierson, expressed to us that one task employees have trouble with is the scrunching of the cake pop bag and securing the bag by tying a twist tie.
Specifically, our subject matter expert, Dan, has limited motor function and one functional hand, making it difficult to complete this task without help from Dr. Renierson or other employees. Our team observed that the main challenge of this task was scrunching the plastic bag and then using another hand to tie the twist tie. Since Dan has one functional hand, we wanted to design a device that would allow the task to be completed with one hand and less stability.
Our original vision for our device started with building a V-shaped base to set our cake pop bag in, and then using two V-shaped arms to scrunch the bag together, with the twist tie also attached to the V-shaped arms to be tied around the bag. This design had a lot of unforeseen flaws that led us needing to redesign and brainstorm new ideas.
We then had an idea to use a string and spool where, when the spool is wound, the string would scrunch together and tie the bag. There were a few issues with our design, primarily the issue of how we would remove the string. Initially, we had a paperclip tied to the string that when pulled would release the string. This design eventually fell through from issues with the spool and opening the string.
We then brainstormed a new design using rails that would have a slider on them to which a twist tie would be attached. The rails were shaped in a way so that when the sliders slid through fully, the twist tie would enclose the bag, effectively scrunching the bag and applying the twist tie. We used on-chip computer-aided design to create an initial model. After the rails and sliders were 3D printed, we were able to create a physical model to analyze. We realized that the rails and sliders were an inefficient method to accomplish our task because they were unable to scrunch the bag properly. We then noticed that the main problem is scrunching the cake pop bag. When we visited Jake's Ice Cream, the employees showed us that they could not scrunch the bag and tie the twist tie at the same time. Therefore, we decided that our device will focus on scrunching the bag so the employees can tie the twist tie around the bag easily. We then revisited the idea of using a string to scrunch up the bag and use a special knot to create a system that can open and close the loop depending on which sides are being pulled. This special knot has 4 different nodes that can be wound up with 4 different stepper motors that we are incorporating.
By winding up nodes 1 and 4 with the motors while simultaneously unwinding nodes 2 and 3, the loop is able to close. Doing the inverse will cause the loop to open up. The loop is held up above the aforementioned V-shaped base with 4 spools attached to motors on the 4 corners of the base that control the loop. The cake pop in its bag is then placed inside the loop in the V, where when someone holds down a button, the loop closes on the bag and allows a much easier application of the twist tie. A separate button can then be pressed, which opens the loop, allowing for the removal of the cake pop.
After we created this design, we noticed issues with the consistency of the process. Sometimes the spools that would need to unwind would unwind too much and the string would come loose from the spools. This made us realize that maybe we could consider a new system. After much experimentation, we created a new knot that used only 2 motors instead of 4, where pulling on each side would cause the loop to open or close. This design came after creating completely new knots and analyzing how they work, and also from testing with elastics. During our observations with Jake's Ice Cream, we realized that it was essentially impossible for Dan, our SME, to tie a twist tie on the cake pop bag. Using our device, it took an average of 21.76 seconds to tie a twist tie on the cake pop bag, which is a vast improvement over the amount of time it took Dan to tie a twist tie. The use of our device also led to significant reductions in the frustration and stress that Dan was experiencing. As Dan is now able to complete the task of tying the twist tie onto the cake pop bag, he experienced much more fulfillment with his work.
After meeting with Jake's Ice Cream for testing, they explained to us that they really liked our device and believed that it will be effective. However, even though our device allowed our SME to easily tie the twist tie onto the cake pop bag, we hope to further increase the efficiency of our device by automating the application and tying of the twist tie.